All right, thank you, Stephanie. Good afternoon. Our presenter today is Dr. Moyed Islam. Dr. Islam is a research faculty here at the University of South Florida Center for Urban Transportation Research. His interests include safety data, analytics, and statistical modeling dealing with the data linkage process for various safety and related data resources. He brings to Qatar the experience of working in the private sector on safety projects related to the implementation of the Highway Safety Manual in different states. He has been actively involved in predictive safety analysis of the Highway Safety Manual, as well as safety data analysis for the Strategic Highway Safety Plan, utilizing state-level crash, roadway inventory, census, vehicle registration, and endorsement data for different emphasis areas. He is actively involved in various TRB committees, including the Highway Safety Performance Committee, the Safety Data Analysis and Evaluation Committee, and the Moped and Motorcycle Safety Committee. He's published more than 15 research reports and peer-reviewed journal papers and presented over 25 presentations at several national and international conferences. And with that, I'm going to hand things off to you, Dr. Islam.
Thank you, Kristen. Good afternoon, everyone. Joining from the Eastern time zone and people from other time zone, good morning. Today I will discuss about the work zone crash analysis in Florida, and it will involve some crash data analysis effort. And but before that, I just want to highlight the disclaimer I want to put here that this analysis effort with the opinion, findings, and conclusion is solely on the researchers, that is myself, and it does not reflect any opinions, findings, or conclusion from the Department of Transportation or any other related agencies. So as I mentioned, this presentation, I'll talk about the work zone crashes in Florida. So the variable in the crash data in crash analysis reporting system cars in Florida, there is a code 2 for that indicates the work zone. So this crash data analysis is based on the work zone related crash, and I will touch on this later this presentation as we move along. So so some of the limitation of this analysis will highlight the project specific information or the safety performance of any particular corridor. It is not included in the crash database, obviously in the Florida, but we could include those information to have a more comprehensive analysis, but this is not the scope for this presentation. So let's look at the safety clock related to work zone crashes in Florida. In most recent year, 2016 and 17, work zone crash occurred in every hour in Florida. So that means next 1 hour, there will be one work zone crashes somewhere in Florida. In every hour, every day, 9 work zone crashes occurred that result in at least one injury. And every week, a one work zone crash result in at least one fatality. Even though these work zone related fatalities and serious injuries do not rank high in the strategic highway safety plan in Florida, but this is important when it comes to this statistics that is published by National Work Zone Safety Information Clearinghouse, where in 2014 Florida ranks third in the nation with regard to fatal crashes in work zone. And in 2016, it went even up to the second position. So this is quite interesting, and it is important that as a safety researcher and safety professional at different agencies to understand the importance of work zone safety and also implement some strategies with the Intelligent Transportation System, ITS, to inform the motorist about the work zone and reduce the risk of the work zone related crashes, especially the fatalities and serious injuries. So in this presentation, I will talk about the trends, especially the temporal and spatial, mostly the district-wise distribution of work zone, its severity and types of work zone, land use pattern, and also the driver characteristics in terms of its demographics and action taken by the driver at the onset of the work zone crash, vehicle type of vehicle types involved in the crashes, work zone crashes. Then I will discuss something a little bit detailed what I have analyzed on the driver injury severity for single vehicle crash in work zone. This analysis is still under review process, so I will very touch on these results and some of the understanding very high level, some conclusion from this data analysis effort, and possible countermeasures and recommendation. So looking at some of the literature regarding the work zone, it is important for Florida because as you see, 20% of the national highway system goes under construction annually every year during the peak summer period, right? And Florida is one of those states which are heavily involved with economic development and with the increasing magnitude of the infrastructure development that will be reflected through the construction area and the work zone. And in work zone, this is a special type of geometric configuration where the work zone workers continue their work and the traffic flow continue at the same time, sometime based on the different condition and the different types of work zone. So there is a natural tendency of bottlenecks that generate from this special geometric configuration that result in some kind of interruption in the normal driving expectancy. So this causes some delays in the traffic flow and also creates some erratic maneuver that may result in crashes and in severe crashes. So this is also important, and FHWA also indicated from their study that work zone is likely to build traffic congestion that will influence some increase in the crash rate. So looking over the work zone crashes over the year from 2011 to 2017, we see the fluctuation happening from 2011 to 14, which is below the average of those 7 years, which is annually about 7,150 work zone crashes in Florida. And 2015 to 2017, as you see, there is an increase in the work zone crashes. Although it will be interesting to see the number of work zone, whether it increased or decreased, but I don't have those information integrated in the crash database. So my analysis is limited to that work zone related crash and crash attributes in this system. So there is an increase happened in 2015 compared to 2014 with 15% increase. 2016 there is a 10% increase from 2015, and in 2017 there is a decrease in 3%. But still the last 3 years there is an increase in the crashes. This is a work zone crash distribution by month in Florida. So you see there is a peak happening in different years from February to April. Most likely it is in March. This data indicates that peak. And the second peak is occurring somewhere between July to September, and it goes up again in August. So there is a peak period in different years by the month. This is the distribution by time of the day in the rural roadway system in Florida. So we see there is a peak. If you look at the top figure on the left side, you will see there is a two peak coming up around 9 a.m. to 12 p.m. And again, the second peak is occurring between 2 p.m. to 4 p.m. And obviously the right bottom figure is showing different year of fluctuation by the time of the day in rural Florida roadway system. Let's look at the urban roadway where the work zone fluctuates over the time by magnitude. If you look at the magnitude, it is quite high. And from 9 a.m. to 12 p.m. there is a peak, but later on this peak becomes more normalized uh, throughout the rest of the days. And the bottom left right figure here is showing the different year of fluctuation by time of the day in urban system in Florida. This is the distribution of work zone crashes by severity. So the red color indicates the severe crashes represented by fatal and incapacitating injury. The blue color represents the minor injury, that is the non-incapacitating and possible injury crash. And the gray color represents the non-injury crash or the property damage crash. So as you see, this pie chart is reflecting about 5 to 7% of the severe crashes over the years, and it is good thing that the number of or the proportion of the severe crash has reduced from 7% to 5% if you look at 2011 to 2017. So there is obviously some strategies that has been taken by different agencies at different time period, and that reflect some of the success of that severity reduction, although the frequency might have increased in 2015, 16, and 17. If we look at the distribution by the district, as I mentioned, some of the analysis will focus on the district-wise distribution. So we see the highest work zone crash share by District 4, 20%, followed by District 5, 19%, District 7, 18%, District 6, 17%, and the lowest work zone crash share by District 3, only 5%. So this is the breakdown of those work zone by years by the district. As you see, the District 5 has increased about, District 5 is the light blue, if you can recognize. The District 5 has increased about 2 to 3 times since 2011 in the time period of 2016 and 17, and District 7 experienced some variation, but it came down in 2017 after a peak in 2014 and 15 time period. This is the severity distribution by district. The red color obviously represents the severe injury crashes. As you see, District 1, if you can see clearly the figure here, District 1, District 7, and 5 has higher severe injury crash proportion compared to the statewide threshold of 6%. And it is interesting that District 6 has about only 3% of severe crash, which is lower than the statewide threshold. And but it has an increased proportion of non-injury crashes in the work zone, about 70%. Let's look at the work zone distribution by county uh, and their percent share. So this is the order of the work zone crashes by different counties in Florida. There are 67 counties, and these counties, if you look at, they have some district represented and on the top. So Miami-Dade County is on the top in the rank with representing District 6, followed by Broward in District 4, followed by Hillsborough in District 7. So if you look at this distribution, that there are 12 counties up to Lee County, it represents about 3/4 of the work zone crashes over the period of 2011 to 17. And there are 3 counties representing District 7. Those are Hillsborough, Pasco, and Pinellas. And there are 3 counties representing District 5. Those are Orange, Volusia, and Seminole counties. This is work zone crash distribution by land use. If you look at this distribution is quite interesting. Most of the work zone crashes are occurring in the urban roadway settings compared to the rural. It is about only 9 to 15% in the rural system, whereas in the urban system it is about 80 to 90% in the urban settings. But we'll see something interesting in the severity distribution when it comes to the work zone crashes. This is the land use by by the district. As you see, this is quite interesting. If you look at District 3 and District 1, the rural work zone crashes are relatively higher compared to the statewide average of 12%, whereas in District 6, it is about only 2% in rural system compared to its predominant urban settings of 98%. So looking at the severity distribution, as I was mentioning to you, that severity distribution is quite interesting when it comes to the rural roadway system in Florida and urban system in uh, you see only 12% of the roadway in rural system represent about 13% of severe crashes in work zone compared to its 7% share in the urban area, that is coming from 88% of its work zone crash share from the urban areas. So this is quite a reverse uh, representation of the severity. So later on, I classified the freeway, principal arterial, collector, and local system based on its attributes in the crash data. And freeway and expressway in the urban area, as you see, it is not quite high compared to its predominant share from the principal arterial, but it has a fluctuation over the year, and in 2016 it is almost 50-50 share by the freeway and expressway in the urban settings and principal arterials in Florida. The interesting thing is occurring in the rural settings, where you see there is a switchover in the freeway and principal arterial in 2013. If you look at the red bar, those are in the decreasing trend since 2011 to 2016 for the principal arterial, and the blue bar is represented by the freeway, that is in the increasing trend since 2011 till 2016. But it is interesting to see in 2017 both of that share came down, mostly for the freeway it came down, and for principal arterial it went up. This is the overview of the work zone types adopted from MUTCD. There are major 4 types of work zone here. Lane closure, as you see, the lane will be closed, so there will be a bottleneck that will create some congestion, slowing down of the traffic. Also, that is also caused by the lane shift and crossover. As you see, the geometry is quite different. And work on shoulder and median, this is another way to maintain the construction work while the flow is continuing, but there is a slowdown and also risk associated with the work. And also the intermittent one is a moving work zone, so it has also some risk associated. But if you can guess where the crash frequency will be higher in these 4 work zone types, or where the frequency of the severe injury will be higher in these 4 work zone types. So we'll see in next few slides how that distribution shows up. Next, the distribution of the work zone types. You see about 1/4 of the work zone crashes are on the lane closure type of work zone, and about 50%, half of total work zone, is related to the work on shoulder or median. So this is quite important that the frequency is quite high on the work on shoulder and median. When the construction plan goes with the flow with the traffic, but it goes sometime by different time of the day. So it is quite interesting, and it is also part of the policy of the agencies how they handle this kind of construction work during the ongoing traffic condition. So if you see here, District 3 and 6 has lower work zone crashes on work on shoulder, uh, about relative to the statewide average, and District 6 has higher work zone crashes on lane closure, as you see 37% compared to the statewide average 16%. And District 6 has also lower work zone crashes on related to the work on shoulder and median, that is 39% compared to the 50% statewide average. This figure is quite busy if you look at the work zone types by functional class distribution. So the principal arterial have almost equal distribution of the lane closure and work on shoulder, whereas in freeway and or expressway has more of the work on shoulder related crashes. And if you look at the district wise, if you look at particularly District 3, the top left figure here, so 100% of the work zone crashes on collector system is related to work on shoulder and median. And also interesting to see that lane shift and crossover is about 27% in the principal arterial. And it is it is higher than the statewide average 17%. If you look at District 5, it is also higher on the local system where it represents work on shoulder has more crashes, 78% compared to the statewide average of 74%. So, and also the District 6 has in the freeway and expressway has lower threshold related to work on shoulder. As you see here, 48% and 35% in District 6. This is work zone crash distribution by shoulder width. This is also important and kind of related to the functional class of the roadway system. So it reflects what type of roadway system it will go under, but it also depends what is the available space during that construction phase. So I categorized the shoulder width, especially the right shoulder here, 0 to 3 feet, 4 to 6 feet, 6 to 10 feet, and 10 feet plus. So if you look at work on shoulder or median is about 44% on 6 to 10 feet shoulder, and this 6 to 10 feet shoulder is mostly predominant in this uh, roadways that has work zone. So this percentage is quite high. And if you look at the district wise, District 1 and District 3 is more predominant on work zone related on the 4 to 6 feet shoulder width of roadways. And rest of the District 2, 4, 5, 6 are all mostly related to roadways with 6 to 10 feet shoulder width if you look at the gray portion in the bar. District 7 has almost equal distribution of 4 to 6 feet and 6 to 10 feet of shoulder width of roadways. So this is quite interesting to see the shoulder width has some impact, and there are studies and also a project I was involved that shoulder width has some implication on reducing the crash frequency in work zone and also the severity. This is work zone crash distribution by location. As you see, the arrow is representing the travel direction going upward in this figure. So there is an advance warning sign, and before that there is also some crashes because of the backward flow of the traffic, right? There could be also multiple vehicle crash, and as we go forward, the number of crashes increases. So the highest crash occur near the activity area, where you see that that bigger portion. So we'll see the distribution here. So about 66% of the work zone crashes are related to the work area, activity area. That is quite high. And if you look at the two ends, the terminal point is on the lower frequency, but it is still something to consider. So looking at the distribution by district, if you look at District 1, District 7, and District 5 has higher work zone crashes in activity area, which is about 73%, 71%, which is higher than the statewide average of 66%. And District 6 has a lower percent share, about 53%, compared to the statewide average of 66%. So looking at the driver characteristics, mostly the demographics, by the age group of different age group involved in different types of work zone. If you look at, so mostly this is related to age group of 30 to 49. And it is interesting if you look at District 3, the driver age group of 30, below 30, is kind of overrepresentation compared to the statewide average if you look at for all of these work zone types. And it is almost the similar distribution, similar equal distribution in District 3 between age group below 30 and age group between 30 to 49. This is quite interesting if you look at the driver action. Let me explain the driver action attribute in the CARS database. So driver action is identified by the investigating police officer at the scene from different process of their investigation, physical evidence, and interview drivers and occupants, and try to identify or determine which are the driver action that caused this crash. So I grouped the multiple categories into an aggressive driving based on my literature search in National Highway Traffic Safety Administration on aggressive driving, and also the Insurance Information Institute. They have a detailed classification where the aggressive driving should belong and what categories of driving action should go under the aggressive driving. I can just briefly touch on some of those that is important here. Following too closely, improper lane changing, illegal driving on shoulder, passing prohibited lane, erratic and reckless driving, failure to yield right of way, traffic sign, or failure to observe warning signal, racing, and merging improperly in a different lane. So these are some of the driving attribute that is very close to the code that I have in the CARS database. So I combine some of those code together to represent the aggressive driving. And the no contributing action is also identified by the police officer. That means there is no action coming from the driver to make some maneuvering to avoid the crash. So this proportion could represent some of the contributing factor from the roadways or environmental aspect of that condition. So it is quite interesting if you look at the database, it is showing that about 40%, 40 to 50% of the crashes are identified no contributing action coming from the driver. But if you look at the driving, aggressive driving, it is about quite the same distribution, about 40 to 45% of the work zone crashes. So this is quite interesting to look at the driver behavior and their action during the work zone, since the expectancy, normal driving expectancy is quite different in the work zone condition compared to the normal driving condition. So there are a lot of maneuvering resulting from the traffic, ongoing traffic and that condition. So there are a lot of action coming from the aggressive behavior of that driving. So one of the strategies from this figure, if you look at, there could be more aggressive enforcement in the work zone area or in the vicinity of the work zone. So driver or reduce their speed and maintain a constant headway or some kind of buffer, so they don't need to make some erratic maneuver at the onset of the crash. So this is quite important here to indicate that behavioral aspect. Let's look at the types of vehicle involved in the work zone. I grouped the passenger car, van, pickup, and SUV into one category, since these are the vehicular passenger vehicle, four-wheelers. So most of those are predominantly by this crash work zone crashes coming from this vehicle. And it is also important to see the heavy vehicle, gross vehicle weight rating more than 10,000 pounds is also quite high. Not so high in the lane closure or the lane shift or crossover, but it is high in the intermittent types of work zone. And rest of the district, if you look at most of these uh, district follow the same pattern as the statewide average distribution of the vehicle types involved in the work zones. So but it is important that we identify the importance and the risk associated with the heavy vehicles and make some strategies so we can avoid that risk coming from the heavy vehicle inside the work zone. As I mentioned, there is a little bit detailed investigation of work zone related crash in single vehicle situation inside Florida, and here I grouped three time period: 2012 to 14 and 2015 to 17 because of their nature of the frequency. If you see, 2012 to 14 has an average of 1,235 work zone crashes, whereas in 2015 to 17, the average of those 3 years is about 1,575 crashes. So there is about 28% increase in that average of those 3 year of time period. But if you look at it, it is interesting, the number of work zone has reduced in 2015, 16, and 17. And it depends on the nature of the work zone uh, and the extent of the work zone in different corridors and the agency documentation. So if I look at the severity, this is what I analyzed detail on the using the advanced statistical model. So looking at the driver injury severity, severe injury crash increased about 26% between those two time period, minor injury 8%, and non-injury crash about 40%. So this is detailed model results. I will not go very detailed into that, but at least I will highlight some of the variable that might be interest for you and for further research. For example, District 7, the work zone crashes occurring in District 7 has higher impact in severe injury crash. The traffic, 10% of truck proportion, 10% of the truck in the total traffic has higher impact on the minor injury crash. As I was mentioning, the right side shoulder width has some impact and implication on the severe injury crash, and this is reflected here. And for single vehicle crash, roadside fixed object is also causing some increased risk with the severe injury crash. This is the result from 2012 to 14. And the modeling approach I adopted is the mixed logit model with heterogeneity in means and variance. Same methodological approach is used in the later time period, 2015 to 17, and some of the factors I can show you that urban interstate has a higher impact on the severe injury crash, looking at the marginal effect, and work on shoulder and median, as I pointed out earlier in the slides, that this has a higher frequency and higher severity, and this is also reflected through this modeling approach. So let's come to the conclusion here. Looking at the trend on the temporal and the locational, focusing on the district, right? So 2015 to 17 has an higher average of work zone crash compared to 2012 to 14. And looking at the temporal distribution, if you remember, during February to April, and again the second peak is July to September till October has a higher work zone frequency. 9 a.m. to 12 p.m. and 2 p.m. to 4 p.m. has a higher frequency in work zone crashes in different years. District-wise share, District 4 has a higher share, followed by District 5 and District 7. Rural roadway system has a higher severe crashes, as we see, even though the representation was in terms of its crash frequency is quite opposite. Activity area, as I mentioned, it is quite higher frequency and also the severity. And the last thing is about the geometric aspect. The shoulder width has something here, and it is about 6 to 10 feet road shoulder width with that roadway system has a higher work zone crashes. From the driver and vehicle perspective, driver age group of 30 to 49 years are overrepresented. And as a present indicated that aggressive driving inside the work zone or in the close vicinity of the work zone need more attention. And passenger vehicle as well as the heavy vehicle needs to be considered with different type of settings and time of the day. As I mentioned very early in the presentation that work zone related crash is based on this attribute, code number 2. It is work zone related, but there is another factor that is quite interesting, that is the contributing factor coming from the roadway geometry, and this is code 4 where it represents the work zone, and there are other factors from the geometric aspect that could contribute to the work zone crashes. I only indicated shoulder here, but there are other attributes. For example, the ruts and bumps and holes, travel surface, roadway surface condition, debris on the surface, traffic control device. There are other factors that could also contribute to the work zone crashes from the roadway geometry aspect. Just to highlight one important thing is that work zone crashes, when we selected as a work zone related crash, is about 50,000 with the code 2, and it also included all the geometric aspect that could contribute to the work zone crashes. But when we include only the work zone crashes that come from the geometric aspect, it is about only 26%. That is about 13,150 crash over this time period, 2011 to 17. So based on the analysis and this data analysis and the modeling perspective, there are some possible countermeasures that can be considered in the work zone safety for Florida, and agencies are adopting this and they have some success stories. If we look at district-wise reduction and different reduction in the frequency and the severity, but it is still important to highlight those countermeasures that could have a possible reduction in the frequency and the severity. Work on shoulder and median needs to be properly designed and managed with the enforcement. This is really important because of the higher proportion. Works on in the rural roadway system has higher severity, so definitely there needs to be more enforcement in terms of speed. Works on in the rural freeway system has needs higher priority, and urban principal arterials also need to be properly enforced and designed. Roadway with narrow shoulder width needs higher attention in terms of design and enforcement in terms of vehicle type, for example, not controlling the excess of heavy vehicles in narrow roadway system in the work zone area. Dissemination of knowledge, this is very critical for the drivers and the motorists who will be passing through the work zone, and it is better to inform the motorist ahead of the work zone period so they don't come into the situation of crashes and the severe crashes. So this message is taken from the Florida DOT website, that don't be that driver that is not informed and not behaving rationally in the work zone area. Also, it is important to deploy the ITS application. There are different applications from the FHWA recommended policies, and dynamic message sign is one of them. There are many other strategies coming with the application of the ITS with the enforcement. And as I was indicating that heavy vehicle is also important in the urbanized area. If there is any way to control the excess of the heavy vehicle in the urbanized area. So these are some of the references help me to understand this analysis and moving with detailed research, some of the motivation of this work. And with that, if you have any question, comments, and suggestion, let me know. And again, at the end, I will just say that work zone safety is everybody's responsibility. This is very truly reflected in the FDOT message dissemination. So it is not only the motorist, it is also the agency side and also the responsibility of the workers. So it is the comprehensive and synergistic approach from the every aspect of the stakeholders. So we can reduce the frequency as well as the severity inside the work zone in Florida.
Okay.
Thank you.
Thanks, Moed. I'm going to, before I hand it over to Kristen to do the moderation of the Q&A section, I would just like to remind everybody on how to ask a question. That Q&A box is located in the bottom right-hand corner of your screen. Simply type any questions and or comments. So Kristen, if you're there, do you want to go through the questions that we have submitted thus far?
Sure, absolutely. Thank you so much. All right, so the first question that we have here is, can you tell us which state ranks the top in terms of fatal crashes in work zones from the National Work Zone Safety Information Clearinghouse?
Yeah, so even though Florida ranks third in 2014 and 2016, it is second, but Texas ranked the top. In 2016, it is about 154 fatal crash, and so up to the recent year, Texas ranks the top, but Florida is also in that. in that, hopefully, it will not go that high in future years. Yes.
All right, thank you. Somebody here is asking where Qatar is located. So the Center for Urban Transportation Research is located at the University of South Florida in Tampa. I just want to answer that real quick. The next question for you, Dr. Islam, is what was your research motivation when you investigated in driver injury in single vehicle crashes in work zones?
Yeah, this is important thing in the crash prediction and a lot of other detail analysis. We assume the factors affecting the driver injury remains constant over the time, but it could vary over the time. So there is a temporal stability of the factors. So that is the major motivation to investigate the different time period to look at whether those factors affecting the driver injury severity is stable over the time and or whether they vary over the time. So it is an interesting work I mentioned very briefly with this slide, and the work is still ongoing. So the findings are coming interesting, and we know that due to the economic up and down, the safety also respond in that level because of the VMT and the exposure, right? So it is an interesting aspect of the analysis. Thank you.
All right, great. The next question that we have coming in is during the presentation, your analysis indicated about shoulder width aspects in the work zone. Is there any study related to this, or can you tell us a little bit more about that?
Yeah, this is a good question because the shoulder width in the work zone is important, and I was involved in one study funded by Indiana Department of Transportation when I was a graduate student. This study is called Super Severity study. So we analyzed the importance of shoulder in different scenario, and available shoulder width is important in reducing the injury crashes because it adds more opportunity for avoiding the crash when there is a onset of crash, and there could be a room to maneuver to avoid that crash, right? Also, widening the shoulder converts some of the multi-vehicle crashes into single vehicle crashes by reducing the risk of secondary event of hitting an already crashed single vehicle crash on the roadway system, and it could be retained in the roadside, and the single vehicle crash could be less severe. So it is important in that nature. And overall, the widening or available or giving some scope to have a wider shoulder will have a positive and direct effect on the severity, improving the severity, I mean lowering the severity in the work zone. And another thing with this study, the CMF clearinghouse, many of you are familiar with that. So the study results is reflected in the CMF clearinghouse. So it shows that increasing outside shoulder by 1 foot can reduce the work zone crashes by 5%. So the CMF is 0.95, and increasing the shoulder width by 1 feet reduce the all work zone crashes by 3%. So the CMF value is 0.97. Thank you for this question.
Sure. And the last question we have for right now coming in is what was the most surprising thing that you learned from looking at the data?
So this is quite interesting. This one of the important things with this detail analysis is the factors that could contribute to the driver injury could be stable over the time, but it may not stable for different state and different time period. So even you think that in work zone, it is very likely that there will be multi-vehicle crash because of the speed reduction and the fluctuation of the speed in the rear end crash. But that may not be true in different years. For example, in 2012 to 14, say rear end crash is a significant factor for driver injury, but that may not be true in 2015 to 17. So the factors changes over time. That part is quite fascinating for me when I'm looking at the work zone, because this is one of the special type of geometric configuration that can influence driver behavior, and there needs a constant communication from the agency side to warn the drivers that there is a work zone coming up, or the speed reduction, or the change in the alignment. So this is quite important. Thank you.
All right. Well, it looks like that brings us to the end of the questions that we've received. If you have any additional questions and you didn't have a chance to ask, just please feel free to contact us and we will get those forwarded to our presenter and we can provide a response to you. A survey should have just popped up on your computer, so if you can please take a moment to give us your feedback on today's presentation, we would greatly appreciate that, and that helps us to cultivate our webcast as we go forward preparing for the 2019 year. Our next webcast will be on November 8th, 2018, and it will be Dr. Steve Pulzine, Understanding Florida Transit Ridership Declines and How We Can Respond. Thank you so much for joining us today, and we look forward to seeing you on November 8th.